Did that work? Oh, this is being even more weird than normal. What is happening? What is going on? I think this is live right now.
Wow. No, really.
But
Men are so weird.
did you say men are so weird? I guess that's kind of true. Women are definitely weird as well. This also says we're live. What the heck is happening? Okay, so we are live. I don't know why it's not showing up here, but it's not. So, if whoever you are and you are out there and you comment on the live, I can't see it today. I'm sorry. I don't know what's happening. Stop streaming. We are live, but it doesn't show up in studio. I don't know what the heck is happening. What if I go to my channel? Can I do it that way? I can do it that way. That'll work. Whoa. Great. All right. You shut up. So maybe I can't see your comments. Ugh. Okay, great. I don't really care about that anyway. All right, test, questions, go. 12. Actually, I might just use this to make my life easier, right? Right. Numero 12. No. It really did not sound Chinese. That was a very strange statement.
Yeah. That was... It's kind of racist.
How is that racist?
I don't know.
Okay, we are expected to find x. So, what should we do?
Find angle G.
Find angle G, absolutely. Sounds great. How would we find angle G? I had several people that broke everything else in this problem, but were able to do that part and knew that you had to do that part. So good job, kids. We weren't totally clueless. So because most of us did that already, you subtract these from 180 and you get 75 degrees. Great.
Now we use the law of sine to say sine 75 over 20.3 equals sine 34 over x.
Throwing this out there, just as a word of encouragement or consternation or something. If what you did on your paper was something like this, or vaguely similar, study better next time. You didn't study well at all if you wrote something like that, because that's not even remotely what law of science says. So if you just wrote like numbers and try to do a proportion, study better next time. You did not study well enough. You might be like, well, I studied. Well, you didn't study well enough. And if you are struggling to study well enough and you want some advice on how to study, I can give that to you as well. If you're like, I know, I just didn't really do it very well this time, then, we're all in agreement. And you're like, I already knew that. That's fine. Okay.
I did do it correct, but I didn't do it that wrong either, so...
Okay, so I did see at least on one or two papers that is a common mistake. This we could maybe argue this wasn't studying well enough. This does not, but I don't know that this is just like you were confused, and it's an easy place to be confused. This is not sine times 75. You can't get rid of the 75 degrees by just like dividing it off. This is not sine times 34 degrees. This is sine of 75 degrees and of 34 degrees. They're all attached. That, in fact, is a number, right? So that's that. I saw that mistake too. So that was just you didn't quite understand something quite right. Okay. So what do we need to do next?
Cross multiply x times sine of 75 equals 20.3 times sine of 34.
Did you get this problem right?
Yes.
Good. Then kindly shut up. I'm being rude just as a joke, but we're going to get the folks that didn't get it right to engage with it. Thank you, sir. All right, what now? What's attached to x?
Sine of
75. How is it attached? So how do you get rid of it? Divide it. Great. Okay, so what are you going to do now? Put in your calculator. 20 times the sine of 34 degrees. You got to make sure your calculator's in degree mode. And if you want to like be sure that you're not going to like accidentally punch it wrong, I would do 20.3 times sine of 34, enter, and then push divide by sine of 75 degrees. You can put it all in at once. If you want to be extra sure that you're not making a calculator mistake, do that in 2 steps.
On the 20.3,
What would it, what? There she goes.
okay.
There she goes. There she goes. Okay, so we end up with what number?
11.8.
On question 11,
Mm-hmm.
it says, is your calculator in degrees? And it was, and I tried it again, and I still got the same answer. So am I plugging it in wrong, or what?
Probably, because if I remember right, everything that you wrote down was correct until the end. So you probably are not. So you probably didn't put something in. You're not putting something in correctly.
So it's cosine, so the negative or
Inverse.
inverse. And then the fraction negative 12/13. Right? And it's in it's there, so there's D, R, and G, and D is the one that's put out.
I did something wrong. Wait, no.
And I still get the same answer. 157.
Use the not reduced instead of the 12/13. So use the 4,000 whatever number. And make sure your SIGN is correct. Make sure that it's supposed to be positive, or your positives and negatives are not wrong. What other questions from the TEST? Okay. 11 and 12 are the hardest problems on the test, arguably, so that makes sense. I didn't say they were hard, I just said they were the hardest. Did you?
Now I got 22.6.
How does that make you feel?
Stupid.
Yesterday, I saw your brother.
Lucky you.
Yeah.
I didn't see him yesterday.
I saw him yesterday because he came over here with a bunch of other hooligans.
Oh, because he's wanting to graduate.
No.
Oh no, the church thing.
Yeah, well, he came after that with the other hooligans.
Oh, funny.
I pretty much call all teenagers hooligans, so that's just like a generic term of endearment at this point, right? Okay. Yeah, he was wearing a cowboy hat, boots, and a ratty T-shirt. So, you know, there you go.
So he's like it.
He's like a prison guard now. I didn't know that he actually got the job. I knew he was trying to be. Okay, so we're supposed to find x.
To use the cosine?
We do have to use the law of cosines. We cannot use law of sines. Why do we have to use law of cosines?
Because we know two angles.
We don't know an angle side pair, right? Yeah, if we had an angle side pair, we could use law of sines, but we don't know a angle side pair, so we can't use law of sines. So we use law of cosines. So what should we do? 20 squared equals 52 squared plus 48 squared minus 2 times 52 times 48
Cosine
times the cosine of x. Now what, kids?
I have a question.
Good.
Why is, like, how do we know which?
So the one that's by is lonesome, the side that's by itself, is the one across of the angle that we're interested in. Good question. Okay. So, what's 20 squared?
400.
It is 400. You probably knew that one in your head, but it's okay. What's 52 squared? 2,740. What is 48 squared?
2,704.
Oh, this one, yeah.
What?
What are you saying?
Okay, so
This is
No,
704.
52 squared is 2,704.
Right.
And then that one is 230.
What's 2 times 52 times 48?
4992.
Okay, then how did I get the right answer if I put the wrong numbers in?
What should we do now?
Combine.
Great. What can we combine?
2704 and 230.
Yeah, and what can we not combine, and why not?
The 4,992 because.
Yeah, because it's not a like term. That's all correct.
I was like, why did I do the numbers wrong? I just flipped 52 plus 48 squared, so I did 48 squared plus 52.
And we get 4,000 some odd. What do we get? 4,000 something?
5,008.
Oh yeah, it is. Then we get 4,000 when we shove it over there. Yeah.
400 totally.
5,008. Okay. What now?
If you subtract it,
Subtract what?
508.
Yeah.
5,000.
Could you also add the 400 to?
Well, if we wanted to move the 400, we'd have to subtract it from both sides, and then we'd have to move that back over to the other side. So, yes, you could if you subtracted. But, okay, what's 400 minus 5,008?
Negative 4,600. 4,608.
Now what?
Divide by negative 4992.
And then we shove that in our calculator. And we end up with x equals
22 point.
degrees.
How's the degrees?
But then the question said we had to round it to the nearest degree.
Oh, it did?
Oh, because of rounding.
Oh my gosh.
No, it said to the nearest 10.
No, it
Also
didn't.
the distance. It says to the nearest degree and sideways to the nearest tenth.
Grant. Any other quick questions from this unit? I mean, well, yes, but this test. Test corrections you turn in on purpose. On purpose, in person.
Number 5.
What?
That was what I probably did this morning.
Yeah.
We're supposed to find the measure of angle R. We know that's 47, that's 56. What trig function are we interested in? Tangent. What is tangent? Opposite over adjacent. So we're looking for the angle. So are we using tangent or something like tangent? We're using the inverse of tangent. Equals the inverse of tangent of 47 over 56. And you shove that in your calculator and push enter.
And we get 40.0.
40.0 degrees. So the difference in that, by the way, slightly continuing that other conversation, the difference between the way that's typically presented, and this actually is one of my irritations between math and science. I don't understand why it's presented in two different ways. In science, there wouldn't be instructions in the top that said round to the nearest tenth. You would look at the sig figs in the problem, and then you would do it. So like this one if it was in a science class, we would be doing 2 sig figs, and you would have gotten it 100% right. And in math, we present it as round to the nearest whatever. And I don't know why it's presented differently. It honestly irritates the fire out of me that it's presented differently. But
So in science, you go based off of how many points it is in the other sides?
well, so you'd have to figure out what is the least significant number in the problem. So if you had 3 numbers in the problem and one had 2 sig figs, one had 3, and another one had 4, your answer would need to have 2 sig figs because you use the least precise measurement. Yeah. Yeah. Nobody has any questions on like 1 or 2? Do we understand those?
We do,
What?
we do 1.
We could do 1.
Can I get a 100 if I correct that?
So 99 averaged with a 100
It's 99 and a half.
is a 100. So you would technically get 100 on the test grade for the unit. Which there is a student in my Algebra 2 class that would definitely do that. She would have already done it. That is the one. Okay. We're supposed to find X and Y, right? Yes? No? Maybe? No calculator. Great. So, what do we do?
To find y, can you put 1 over 1?
I would find X first. What would be helpful to label on this triangle? No.
It wasn't a sine, so
It is a 30, 60, 90.
I
That is a great way to start.
And then do you put 1 over 2?
No.
Look at me drawing.
To get from the 2 side to the 1 side, what do I do?
Subtract 1?
No. How do I get from 2 to 1? You gotta use multiplication or division. Addition and subtraction doesn't make any sense in context. Divide by 2. So what does x equal? What is 8 divided by 2?
4.
Thank you. Now that we got the 1 side, how do we get to the square root of 3 side?
You put 4 multiply times square root.
Yeah. So I don't remember, because here we are today. Did I give y'all a video and y'all watched a video and notes, or? Okay, great. Then what homework problems did you do?
16 through
There's probably pictures involved.
18 on 2 of them.
All of them said graph.
How did you graph the answer to you? 24 and 6?
All right, we did what numbers?
18 through 28.
18 through 28 evens. Yeah, everything's got pictures. Reading's hard. Never lose access. Add account recovery. I don't really want to do that. It's the challenge channel. That's the only thing that ever plays on this channel. We should know this by now. Well, look, there's some people's grades. That's how you die.
My sleep paralysis.
Maybe you mess up.
You actually have sleep paralysis?
I don't even know what it is.
There's 18.
Why is there like
You're supposed to graph the original and then the reflected one. So the darker one is the original. The paler one is the reflection.
I mean,
when do you just pull it up?
No, because you're not translating, you're reflecting. Number 20 looks like that one.
wait, okay, so on 18, I'm just confused. Could you go back up? Because I did it, it looks exactly like that,
Except it doesn't.
Oh, okay. Because I was like, why is y -3? But that's not the y. Never mind.
That's the line that it reflected over, right?
Right,
Yeah.
I did it.
Good.
Flip it over.
Number 22. Oh, hold on. I got to go back and point the camera at the screen so that our students that aren't here will know how wrong they were or how right they were. That's a retarded statement.
What?
That's a retarded statement. Men don't have high IQs. Some men don't have high IQs. Some women don't have high IQs. That's kind of how IQ works. Some people don't have high IQs.
Well, I was about to say that women don't have any IQ at all.
Well, that wouldn't be true.
I see. Well, that one's even more dumb. Do you people know where IQ research started? What they were trying to do when they first started doing IQ research? Or who did the research? You could probably guess who did the research because it's always who did the research.
My guess is
Sigmund
No.
Freud?
Nazi Germany.
No, the
It is
The-
a fair guess.
the Army did
Oh,
IQ research.
That's very
You want to know what they were trying to figure out and to do? Would you like to know? I'm going to tell you anyway.
See who to put.
They were trying to see who to shove on the front lines.
So it involved Nazi Germany.
It involves Nazi Germany-like things.
yeah, that would be.
Yep. They also, the U.S. military, I think still the Army, was also the original research on type A and type B personalities. True enough.
Did you show answer 22?
I thought I did. I don't know. Let's go back to there and see. 22 is that away.
So what are type B and type A personalities? Because I've heard of
The research was trying to see if really it wasn't really about type B personalities, or nobody talks about type B personalities, A's and type A personalities. When people say somebody's a type A personality, may or may not be true. They probably don't understand. And the research, possibly, but it really was looking at heart disease. It was trying to say, and they did find that type A people are more likely to have a heart attack. That there is definitely evidence that that is true.
I have like a miniature.
Number 26. And finally, number 28. Ooh.
What? Well, I did that one wrong.
So 28 is not a picture.
28, let's see what the destructions say. Given each figure, describe the transformation used.
Can we do 26?
Yeah, we can do 26, sure.
That's the only one wrong.
Only one you got wrong.
Oh, I'm just gonna know.
Well,
Oh, I know why it's the only one I got wrong. Because it's the only one with the slanted thing.
Okay. Good luck to us. We're doing 26, bro.
That one was the most difficult because you had to go, you didn't actually have a line to think about.
A line? You didn't have a line to think about, you had a line?
You had this,
That's a line.
it wasn't a.
Horizontal or vertical. We're actually finding on this one, you're finding the inverse, because that's what the inverse of a function is the reflection, well, graphically, that's what it is. Reflection over the line y equals x.
I have a question about that.
Okay?
Could you just reverse which one's positive and which one's negative in the numbers? If the original was -4 and 2, could you go to 4, -2?
That's not mathematically what happens when you find the inverse. But you're kind of on the right track. You can flip something, but it's not that.
Numbers, so it would be
Yeah. Yeah, you replace the domain and
2,
range.
-4.
Yep. Yes, that is, and y'all wouldn't necessarily. I mean, you might if you had a kind of advanced algebra 1 class, you might remember and know to do that and think about that. But other than that, at this point, you probably wouldn't necessarily like jump to that thought. And we're supposed to reflect this over the line y equals x. So, because we are in March and we're headed towards Algebra 2, I will kind of talk through what we were just saying again, but with exactitude. So, when you take a function, this is not a function, this is just a figure, and you reflect it over the line y equals x, what you are finding is the inverse of that. And anytime, and regardless of that, so anytime you're taking something on a graph and you're reflecting it over the line y equals x, all you have to do is exchange the domain and range. So you have to take and flip the x and y. So our f prime in this case would be 2, -3. Our g prime would be -1, -4. And our h prime would be -1, -6. So grabbing the original would go -3, -1, 2, 3, 2, 1, 2, and then -4, -1. So this is F and G, and then -6, -1. So we're talking about this little triangle, right? And then it should, assuming that I'm not lying to you or having a conniption of some sort, if we go to graph these other ones, it should reflect beautifully over this line. So let's see if I'm lying to you. 1, 2, -3. 1, 2, -1, 2, 3 is right here. This is F prime. And then G prime is -1, -4. 1, 2, 3, 4. And then H prime is -1, -6. So it looks to me like it was not, in fact, a lie.
So you just switch the thing.
Yes, anytime we're reflecting across the line y equals x, you just switch the domain and range. Easy money. Sure.
So y equals x is going from bottom left to top right. Is x equal y going from top left to bottom right?
They're the same.
It's the same.
Yeah, functionally the same. We just usually, so in slightly not, well, it is generic terms, x is the independent variable and y is the dependent variable. We usually write the dependent variable on the left and the independent variable in the function mess on the side. And especially because we usually use function notation, and y would actually be like f of x or whatever, because it's more descriptive and it tells us what we're doing. So yeah, x equals y is the same, functionally the same. $22. Okay. I need to buy me a new set that's not broken. I feel like I need a bigger Doomy Flotchy for stuff like this. These ones, like this, I would argue are easier to do just graphically, like visual, like counting stuff on the picture. But let's see. Going down 1, 2, and over -2. We got W. And then we're over 1, 2, 3, 4, 5. We got X. 1, 2, 3, 4, 5. We got X. And then we've got Z down a whole heap. 2, 3, 4, 5, 6, 7. 2, 3, 4, 5, 6, 7. We have a Z So right here is y. And then that's beautiful. And we are expected to reflect this over the line y equals -4. Is that right? So there it is. So I would start personally by dotting in that line. Because it's going to be easier to figure out what's happening. This is y equals -4. And we're supposed to reflect all of that over that line. So what would we do?
See how many it takes to get to the line from each negative that much.
This one's going to come right there, yeah? And this one's going to go. Wait, did I go too far? Yes? No? Well, kind of. My ugliness. It's right here. Right? You don't want to label these. Like, where is this W prime? What is the point? The coordinate? Well, W is -2, -2. But what's W prime after it's reflected? -2, -6. And then y prime, no, this is x prime, is at where? 5, -6. So I'm up here just doing things. Does this make sense? Do we understand what's going on?
No, I don't get where to put it after you put it in.
So how far up from this line is this? How many spaces is here? 2. So if I reflect it over, it's going to be 2 spaces here. So this, we're reflecting, so 2 spaces down from -4 is -6. Same thing with this one. So this one, this y is going to get reflected this way. So this a difference of 1 space. So it's going to be up 1 right here. So y prime is where? 4, -3. The 4 because it didn't change this way, it only went this way. The -3 because that's where it goes 1 distance from there.
Do we have to write out the new points?
Yes.
Okay.
You don't have to put it like on the graph. If you want to put it like to the side, whatever it makes more sense to you, that's fine. But yeah, you would have to write the new coordinates. So all we need is z. So it's 3 distant from here. So 1, 2, 3 would be right here. So z prime is where? 0, -1. And then you just connect those dots on there. And you got it graphed. Yours on graph paper will look better than mine, but that is what you would do. You definitely could do these without a picture. You definitely could do them algebraically and get there, but on these, it's probably easier to just do it with a picture. So that's kind of up to you. Reflections and rotations are the trickier bits. Translations and even dilations are pretty easy. You just like add and subtract stuff and then multiply stuff if it's dilation.
Dilation is whenever you move it to a higher scale, right?
Yes. And dilation, so if you learned dilations previously, you almost certainly learned all of your dilations dilating from the center of the shape. So like to here to here or here to here. But in our high school level dilations, you're dilating almost always from the origin. So you'll have it like you might start with a small shape and end up with a big shape, or start with a big shape and end up with a small shape, and it'll look like it's translated and dilated, but it's only dilated just based on where your focal point is. But you'll see that when you get to that lesson. It's really actually pretty easy. You just start multiplying stuff.
So for the y,
Mm-hmm.
how do you know like where to put it? Because you put it at like an angle from the y. Do you like do it exact? Like do you count over from the original?
So what's changing is this y direction, right? So it's going to be in the same x plane, right? So this part, and you notice y and y prime have the same number. This one is 4 negative whatever, negative 5. So this one's 4. So then it just goes up above that. So you're not counting like from the origin to get there. You're just counting from where you're reflecting up 1 from there in this context because it was down 1. Does that make sense? Any other questions on this lesson, kiddos? Well, we have one more week next week, and then we have spring break. Yay. Oh. Nobody reminded me to flip the camera around.
I thought it was kind of funny.
That's sadistic. That's the problem we were doing. Camera people, I apologize.
Do you have a hole puncher that I could borrow?
Yeah, the good one is sitting on my desk.
You take your thing back.
That's not mine. I can have it. I'll take it.
That pen has been floating around in here for a while. I have no idea where it came from.
I didn't even